Download this code from codegive.com, link in the description below. Reading files into byte arrays in Java, 7 comprehensive examples. Reading a file into a byte array is a fundamental operation in Java, essential for various tasks like file manipulation, data transfer, encryption, and more. This tutorial provides 7 distinct methods to accomplish this, showcasing different approaches and their strengths and weaknesses. We'll explore the use of fileinputstream, files.readallbytes, and other techniques, highlighting error handling and best practices. Before you begin, ensure you have a Java Development Kit, JDK, installed and a basic understanding of Java.io. We'll use the java.io and java.nio.file packages extensively. Example 1, using fileinputstream and a byte array. This is a classic approach, offering fine-grained control. Strengths: simple, direct access to file contents. Good for smaller files. Weaknesses: requires manual resource management, try finally. Reading the entire file into memory at once might be inefficient for very large files. Doesn't handle potential I/O exceptions gracefully in the read method itself. Example 2, improving error handling with fileinputstream. This example enhances error handling by checking the return value of fis.read. Strengths: improved error handling, handles files that might not be fully read. Example 3, using files.readallbytes, NIO. This method from the java.nio.file package provides a more concise and efficient way to read files, especially smaller ones. Strengths: more concise, handles resource management automatically, try with resources is implicit, efficient for smaller files. Weaknesses: can be memory intensive for extremely large files, throws out of memory error if the file is too large to fit in memory. Example 4, buffered input stream for improved performance, large files. For larger files, buffering improves efficiency. Strengths: significantly faster for large files due to buffering. Example 5, handling potential exceptions during read, fileinputstream. This example adds more robust exception handling within the read loop itself. Strengths: more robust exception handling within the read loop. Example 6, reading in chunks, for very large files. To avoid out-of-memory error with massive files, read in chunks. Strengths: handles extremely large files by reading in manageable chunks. Weaknesses: slightly more complex than other methods. Example 7, using mapped byte buffer, for random access. Mapped byte buffer allows for efficient random access to the file's contents. Strengths: efficient for random access, can be beneficial for certain applications. Weaknesses: similar memory constraints as files.readallbytes, for large files. Choosing the right method small files files.readallbytes, is the easiest and often most efficient. Medium-sized files buffered input stream offers a good balance of simplicity and performance. Large files the chunked approach, example 6, is crucial to avoid out-of-memory error. Random access mapped byte buffer provides optimal performance for scenarios requiring random access. Remember to always handle potential I/O exceptions appropriately and choose the method best suited to your file size and access patterns. This comprehensive guide equips you with the knowledge to effectively read files into byte arrays in Java, regardless of their size or your specific needs. Remember to replace my_file.txt with the actual path to your file. Reading files into byte arrays in Java, 7 comprehensive examples. Reading a file into a byte array is a fundamental operation in Java, crucial for various tasks like image processing, data transfer, and file manipulation. This tutorial explores 7 distinct methods to accomplish this, ranging from basic to more sophisticated approaches, highlighting their strengths and weaknesses. We'll cover exception handling and best practices throughout. Prerequisites * basic Java knowledge, including file I/O concepts. Before we begin * remember to handle potential exceptions, like I/O exception, appropriately. The examples below demonstrate this using try-catch blocks. Always include error handling in production code. Example 1, using files.readallbytes, Java 7+. This is the most straightforward and often preferred method for its conciseness and readability. It leverages the files class introduced in Java 7. Advantages * simple, efficient for smaller files. Disadvantages * can be memory intensive for very large files, loads the entire file into memory at once. Example 2, using fileinputstream and readallbytes, Java 7+. This method demonstrates using fileinputstream for more granular control, though files.readallbytes is often preferred for its simplicity. Advantages * similar to example 1 but offers more control over the input stream. Disadvantages * same memory limitations as example 1, readallbytes, is only available from Java 9 onwards. For earlier versions, see example 3. Example 3, using fileinputstream and manual reading, pre-Java 9. This is a more manual approach suitable for pre-Java 9 versions or when you need finer control over the reading process. Advantages * more control, handles large files more efficiently, though still loads into memory eventually. Works with older Java versions. Disadvantages * more complex to implement than readallbytes. Example 4, using random access file, for seeking and partial reads. Random access file allows for random access to the file, enabling efficient reading of only specific parts. Useful when dealing with very large files where loading the entire file into memory isn't feasible. Advantages * random access, efficient for large files if you only need parts of it. Disadvantages * more complex to use, still loads the entire file if read fully is used as shown. More efficient for partial reads using raf.read, byte, offset, length. Example 5, using buffered input stream, for improved performance. Buffered input stream improves performance by buffering reads, reducing the number of disk accesses. Advantages * improved performance for larger files due to buffering. Disadvantages * slightly more complex than files.readallbytes. Still loads the entire file into memory. Example 6, mapped byte buffer, for memory mapped files. Mapped byte buffer maps a file directly into memory, providing very fast access. Ideal for large files that need to be randomly accessed frequently. Advantages * extremely fast access for large files, efficient for random access. Disadvantages * more complex to use, requires understanding of mapped byte buffer and memory management. Can lead to memory issues if not handled carefully, file size is limited by available memory. Example 7, using java.nio channels, for asynchronous, non-blocking I/O. This approach utilizes channels for asynchronous file reading, particularly beneficial in applications requiring high concurrency and responsiveness. This is a more advanced technique. Advantages * asynchronous reading, suitable for concurrent applications. Disadvantages * more complex, requires understanding of asynchronous I/O concepts. Choosing the right method *. The best method depends on your specific needs. * small files * files.readallbytes, is the simplest and most efficient. Asterisk large files, sequential access file input stream with a buffer, example 5, or buffered input stream is a good compromise. Asterisk large files, random access file or mapped byte buffer offer better performance. Asterisk high concurrency asterisk asynchronous file channel is the most suitable. Remember to always handle I/O exceptions properly and consider the memory implications, especially when dealing with large files. Always choose the simplest solution that meets your performance needs. For extremely large files that exceed available memory, consider processing the file in chunks, using methods like read, with a buffer. Remember to replace my_file.txt with the actual path to your file.